Using ratios to compare length, area, and volume. If the ratio of a length is A to B, then the ratio of the areas is A squared to B squared, and the volumes A cubed to B cubed. So notice the advantage of having this ratio, this length ratio. You don't have to use area formulas to compare the areas. You don't have to use volume formulas to compare the volumes. All you have to do is run it through these two simple formulas. Here's an example. What happens to the area of a circle if its diameter is quadrupled? So notice, here's the diameter. Quadrupled means 4 times bigger, so 2 times 4 is 8. So the diameter has been quadrupled. These are length measurements, so I could create my ratio. 2 to 8. That's the way the lengths compare. Once you have this length comparison, you could use it to say something about the area comparison just by squaring both numbers in the ratio. So it's 2 to the second is 4, 8 to the second 64. Simplify, we always simplify with ratios. And now we know that if you quadruple the diameter, the areas will compare this way. So the second area is 16 times larger than the first area if the diameter is quadrupled. This next one is another type of problem. B, what happens to the area of a circle if its radius is increased by 20%? So they mentioned the area of a circle. Here's the formula. And we're going to increase the radius by 20%. So it's r plus 20% of r. So increase, that's why we would put a plus. If it was decrease, we would put a minus. But this is increase. So it's r plus a little bit more, 20% more of the r. Notice it stays within the formula. The power of 2 is still there. So now you simplify. You could add these two. This is 1r plus 0.20r is 1.20r. Now you square it, and you get this. So this was the original area before the increase of 20%. And after the increase of 20% of the radius, this is the area. So what happens to the area? What happens to the area of a circle if the radius is increased by 20%? Well, notice that this one, the original, had a 1. This one has 1.44, which is what we have here. So the 1 is still there. This is the 1. This is the 1. This one has a little bit more. It has 0.44. So the area has increased by 0.44. Change that to a percent, move the decimal twice, tag on the percent symbol. So you move the decimal twice, tag on the percent symbol. So we could say now that the area has increased by 44%. This one is like the first one we did, like part A. What happens to the area of a circle if its circumference is doubled? Well, circumference is the length. It's the length around the circle. Here's the circumference formula. So now suppose the circumference is 3 inches. And it says suppose we double it. Well, that would be 6 inches. You could pick whatever number you like. It's a simple number. So 3 doubled is 6. And now since you have the ratio of lengths, remember you have to have the ratio of lengths, 3 to 6. All you have to do is square the 3, square the 6, and this will produce the comparison between the areas. You always reduce, divide this by 9, divide this by 9. So it's 1 to 4. So the area went from 1 to 4, that means the area is 4 times larger.